自荐 CFC2409009. Today I will talk about the practical exploration of derivative and integral. My presentation includes 4 parts. Part 1. Application of derivative to economic. Part 2. Example of virtual method to find the value of a solid of revolution. Part 3. Explain of century of mass and the moment. Part 4. I will make a short summary. Okay, let's look at Part 1. Application of derivative to economic. Derivative play an important role in economic. For marginal analysis optimization problem, studying the dynamic change and so on. They provide insights into cost, revenues, and profit. Let's break this into key components. 3 important functions in economic: cost function, revenue function, and profit function. Let's first talk about the cost function. It represents the total cost of producing X unit of product, and it includes 2 parts: fixed cost and fixed cost. The costs net are independent of the quantity of producing, such as rent, salary for the staff, and so on. Variable cost. The cost net depends with the increase in quantity X. Together, they form Cx equal Fc plus Vcx. And using the derivative, we derive the marginal cost function. What is the significance of taking the derivative of the cost function? The marginal cost function shows the additional cost of producing 1 more unit of a product. For example, the cost function is 2x squared plus 10x plus 15, and taking derivative, the marginal function is 4x plus 10. As the graph shows, the marginal cost increases as production grows. This indicates that producing too many units may not be cost efficient. At X equal 5 units, MC5 equal 30. This means producing the 6 unit will cost an additional 30 units of currency. In short, the marginal cost function helps business decide whether increasing production is worth the extra cost and ensure better cost management. And then the next, revenues function. It represents the total revenues obtained by selling X unit of a product, and Rx equal Px multiply X, and Px is the price function of the per unit of the product. And the marginal revenue function, denoted as MRX, is the derivative of the total revenues function Rx. It represents the additional revenue earned from selling 1 more unit. If the marginal revenue function is Rx equal 100x minus x squared, and MRX equal 100 minus 2x. This means selling the 6 units adds 19 units of revenues. In summary, the marginal revenues function helps determine the most profitable production level and highlights how revenues growth changes with output. Then we can go to the next, the profit function. Maybe we are familiar with the profit, and the profit function represents the total profit when selling X unit of a product. Because profit equals the revenues minus profit minus cost, so the profit function equals revenues function minus cost function. Also, use the subtraction rule for the derivative. Marginal function profit function can not only represent the derivative of profit function, but also can represent the marginal realness function minus marginal cost function. Also, as the graph shown, profit increased initially as sales grows, and the profit reached a maximum point beyond which it starts to decrease, indicating diminishing returns or increased cost. The marginal profit function shows how profit changes with each additional unit sold. When MPX equals 0, profit is maximum. Solving 18 minus 2x equals 0, we get x equals 40. If the sales continue beyond this point, beyond 40, MPX becomes negative, meaning additional sales reducing overall profit. So business should aim to sell 40 units to maximum the profit. Business should aim to. Okay, this is the application of derivative in economics. Now we can go to the next. The example of Washer method to find the value of a solid of revolution. In our daily life, calculating the value of the solid of revolution is very common scenario. Just like the water pipe, we want to calculate the value of the pipe's wall. After the mathematical modeling, we can use the Washer method to solve it. If the R out is 5, R inner is 3, and the length of it is 10. So the value of it is pi times the integral from 0 to L of the quantity R squared minus R squared with respect to x. Then we can get the answer. Okay, next, the explanation of the moment and the center of mass. For simple case, we calculate the moment using this. Moment is the quantity that describes the rotation effect of a force about a point or x, and it equals to F multiplied d. The F is the applied force and the d is the level arm. However, when the force is distributed across a continuous object like a rod or beam, we need to use integration to calculate the total moment. The formula is integral from a to b of x times fx dx. Then, the center of mass. The center of mass is often referred to the balance point of an object's mass distribution. It is the weighted average position of all the mass in an object. Imagine trying to balance a ruler on your finger. When your finger is directly under the center of mass, the ruler won't tip. For continuous objects, the center of mass isn't always obvious. To find it, we need to use integration. The formula for the center of mass here. Use it. We can find where is the center of mass. Here is a simple question. When we understand the concept of the moment and the center of the mass, just substitution the condition into the formula, and then we can obtain the answer. Okay, these are the process of solving the problem. Okay, let's make a summarize. We have explored three key topics today. First, the derivative in economic. Derivatives are powerful tools for analyzing and optimizing revenue and profit. Through practical example, we saw how marginal value guides decision-making in business. Second, the virtual method. This method provides a practical way to calculate the value of hollow solid, such as pipes, using integration. It bridges the mathematical theorems and real-world application. The last, moment and the center of mass. This concept demonstrates the balance of force and rotation efforts. By understanding moment and using integration, we can locate the center of mass and analyze the physical system. Effectively. Each of these topics highlights how mathematical tools help us to solve complex real-world problems in economics, engineering, and physics. I believe in future study, calculus will play a crucial role. Okay, that is all. Thank you for listening.